Have you ever been on a Ferris wheel? It's a giant wheel that takes you round and round. Up you go, then down you come. The unit circle is kind of like that. It's a special circle in math. It helps us understand things that go in circles. This circle has a center. We call that point 0, 0. The circle also has a radius. The radius is the distance from the center to the edge. The unit circle's radius is always 1. That makes it easy to work with. We use the unit circle to learn about angles and distances. It helps us understand how they're connected. Imagine a point moving around our unit circle. This point is like a traveler on a journey, always moving, always changing its position. Like that Ferris wheel car, up and down it goes. The motion is continuous, just like the point on our circle. As it moves, it makes an angle. We call that angle T. This angle is crucial because it helps us understand the position of our point at any given time. Now we're ready for sine and cosine. They sound fancy, but they're just ways to track our point. Think of them as coordinates that help us pinpoint the exact location. Sine is all about the up and down. We write it as sin when it's like measuring the height of our point as it travels around the circle. It tells us how high the point is on the circle. This vertical measurement is essential for understanding the point's position. Cosine is about side-to-side motion. We write it as cos t. It's like measuring the horizontal distance of our point from the center. It tells us how far left or right the point is. This horizontal measurement complements the vertical one, giving us a complete picture. Sine and cosine are like partners. They work together to tell us exactly where the point is on the unit circle. Without one, the other wouldn't be able to give us the full story. They are super important for understanding triangles and waves and all sorts of cool stuff. From engineering to music, these concepts are everywhere, making them fundamental to many fields. There are some angles we see a lot in trigonometry. They're like VIPs. These angles are 30 degrees, 45 degrees, and 60 degrees. We also have 0 degrees and 90 degrees. These special angles make special triangles. These triangles have sides that are related in simple ways. We can use those relationships to find the sine and cosine of those special angles. For example, a 45-45-90 triangle has two sides that are equal. That helps us find the sine and cosine of 45 degrees really easily. These special angles are like shortcuts. We can use them to solve all sorts of problems without doing tons of calculations. They make working with the unit circle a lot easier. We can figure out sine and cosine for special angles. But what about other angles? That's where calculators come in. They have special buttons just for sine and cosine. They make our lives so much easier. But hold on. Calculators can be tricky. They need to know if we're talking about degrees or radians. Degrees are like slices of a pizza. Radians are a bit more complicated, but they're important too. Make sure your calculator is set to the right one. Once your calculator is ready, just type in the angle and press the sine or cosine button. Boom! The answer pops right up. Calculators are great tools for working with sine and cosine, especially for angles that aren't so special. Section 5. Domain and range. The limits of sine and cosine. Sine and cosine are powerful, but even they have limits. The domain is all the possible angles we can put into sine or cosine. Think of it like the ingredients for a recipe. We can use any angle we want. The range is all the possible answers we can get back. It's like the finished dish. No matter what angle we use, the sine and cosine will always be between -1 and 1. They can't go outside that range. Understanding the domain and range helps us know what's possible with sine and cosine. It's like knowing the rules of a game. Once you know the rules, you can play and have fun. Section 6. Reference angles. Mirroring your way around the circle. In this section, we will explore the fascinating concept of reference angles and how they help us navigate the unit circle. Sometimes we have angles bigger than 90 degrees. These larger angles can be tricky to work with at first. That's when things get really interesting. These larger angles open up a whole new world of possibilities in trigonometry. Reference angles help us figure out sine and cosine for these bigger angles. They act as a bridge, connecting what we know about smaller angles to these larger ones. They're like mirrors reflecting the angles back to a place we know. This mirroring effect simplifies our calculations and makes understanding easier. A reference angle is the smaller angle formed between the x-axis and the line representing our bigger angle. This smaller angle is always positive and less than 90 degrees. It's always between 0 and 90 degrees. No matter how large the original angle is, the reference angle will always fall within this range. We can find it by subtracting the bigger angle from 180 degrees or 360 degrees, depending on which quadrant our angle is in. This method ensures we always get a positive reference angle. Reference angles are like secret shortcuts. They provide a simpler path to solving trigonometric problems, making our work more efficient. They let us use what we know about the first quadrant to figure out sine and cosine for any angle. By understanding the first quadrant, we can extend this knowledge to all other quadrants. They make trigonometry much less mysterious. With reference angles, we can tackle even the most complex problems with confidence and ease. Section 7. Using reference angles. Finding sine and cosine anywhere. Reference angles are like keys that unlock the secrets of the unit circle. Once we know the reference angle, we can figure out the sine and cosine of any angle, no matter how big or small. Here's the trick. The sine and cosine of an angle are the same as the sine and cosine of its reference angle, but the sign might change. The sign depends on which quadrant the original angle is in. We can remember the signs with a little saying, all students take calculus. By using reference angles and the quadrant signs, we can navigate the entire unit circle with confidence. It's like having a map and compass to guide us through the world of trigonometry. Section 8. Coordinates from reference angles, mapping the unit circle. Reference angles are super helpful for finding coordinates on the unit circle. Remember, every point on the unit circle has an x-coordinate and a y-coordinate. These coordinates tell us exactly where the point is. To find the coordinates, we start with the reference angle. Then, we use what we know about sine and cosine for special angles. We just need to remember that sine gives us the y-coordinate, and cosine gives us the x-coordinate. Once we have the sine and cosine values, we look at the quadrant of the original angle to figure out the signs. Then we're done. We found the coordinates of the point. It's like we're explorers mapping out the uncharted territories of the unit circle. Section 9. Real-world trigonometry, from Ferris wheels to sound waves. Trigonometry seems like something you only do in math class, right? You might think it's just about solving equations and drawing triangles. Wrong. It's all around us. Remember that Ferris wheel? It's not just a fun ride. It's a perfect example of trigonometry in action. We can use sine and cosine to figure out how high the cars are at different points on the ride. Each position of the car can be described using these functions. Trigonometry helps us understand sound waves too. When you listen to music or hear someone speak, you're experiencing trigonometry. Sound waves are like ripples in the air. Just like ripples in water, they move in patterns that can be described mathematically. We can use sine and cosine to describe how those ripples move and how we hear different sounds. This helps sound engineers create the perfect audio experience. Trigonometry is even used in GPS systems to help us find our way. It calculates distances and angles to pinpoint your exact location. The unit circle, sine, and cosine are powerful tools that help us understand and describe the world around us. Scientists and engineers use these concepts every day. They're not just abstract math concepts, they're keys to unlocking the mysteries of our universe. From the smallest sound wave to the vastness of space, trigonometry is everywhere. Section 10. Practice makes perfect, mastering the unit circle. Learning the unit circle takes practice, but don't worry, it's like riding a bike. The more you practice, the easier it gets. Start by memorizing the sine and cosine values for the special angles. Those are your building blocks. Then, practice finding reference angles and using them to figure out sine and cosine for other angles. Draw unit circles and label the angles and coordinates. The more you work with it, the more comfortable you'll become. You can even make flashcards or use online quizzes to test yourself. Don't be afraid to make mistakes. That's how you learn. The important thing is to keep practicing and have fun with it. Section 11. The adventure continues. Trigonometry beyond the basics. Congratulations! You've taken your first steps into the exciting world of trigonometry. The unit circle, sine, and cosine are just the beginning. There's so much more to explore. You'll learn about other trigonometric functions like tangent, cotangent, secant, and cosecant. You'll delve into fascinating identities and formulas that reveal hidden relationships between angles and triangles. You'll even discover how trigonometry connects to other areas of math, like algebra and calculus. So keep exploring, keep asking questions, and keep practicing. The world of trigonometry is full of amazing discoveries waiting for you.